Welcome to SmithWeekly Discussions, an occasional program for our readers and listeners of SmithWeekly Research. Please note this program is a private discussion, and everything contained herein is for entertainment and educational purposes only. With that, we hope you're in a comfortable position, along with your favorite beverage, to enjoy the discussion. We want to thank our audience for questions coming from Randy D., Jimmy Z., Luke A., and Dave V. Jay Surina has joined us. Jay is the Chief Financial Officer of Nuscale Power, a company that is leading the change in the nuclear power industry with small modular reactors, also known as SMRs. Beyond nuclear, Nuscale is looking to deploy widespread power for all humankind. Nuscale is based out of Portland, Oregon, and has a number of offices around the globe. Jay, thanks for coming on.
Thank you. Really appreciate the opportunity to talk with you and get our message out to your listeners.
Jay, so tell us a bit about your background and why did you end up at Nuscale?
Well, so I've been at Nuscale for almost 10 years now, since Nuscale was only about 20 employees back in the 2008-2009 timeframe. My background is I'm not a lifelong nuclear power career person, but I do have background from being in the nuclear Navy back in the mid to late 80s, where I was a nuclear submarine officer. And when I got out of the submarine Navy, got my MBA, and decided to stay in the energy realm, prior to coming to Nuscale, I've been working for mostly private companies in the energy space and the generation of electricity, whether developers or companies like that. So I've been in the space for a while, but this is my first foray back into nuclear power since my Navy nuclear days.
Okay. Well, Jay, on that subject, can you tell us what the name of the submarine was, and maybe give us just a little glimpse of your experience in that business and that kind of task?
Sure. So the submarine that I was mostly on when I was a junior officer was the USS Miami, which has been decommissioned. It actually got decommissioned several years ago because there was a fire on board that was deliberately set. So it's no longer in existence, but the submarine that I was on was commissioned in 1990, and I got to the submarine in 1987 and was there from 1987 to 1991. And pretty much had a lot to do with helping to commission the nuclear reactor on the submarine, and then as a junior officer to be a watch officer on the nuclear submarine. So I spent a lot of my time in the engineering spaces, spent a lot of time studying to get to be engineer qualified, which I was engineer qualified on the reactor that was on the Miami, and really enjoyed the opportunity to learn all of that during a period of time especially when the submarine Navy was a little bigger than it is today, and during a period of time when it was unclear, given the world situation, what might happen shortly after. While I was leaving the Navy, things settled down a bit with respect to the Soviet Union falling apart. But I was happy to be commissioning a submarine, working in nuclear power, and doing all that during that period, which was a very interesting period of time.
Well, what an experience to be able to do that. I mean, it certainly takes some expertise and some skills, and to be able to be involved with that, and quite fascinating for me anyway. So very, very good. Appreciate the information on that. So moving on, sentiment regarding nuclear technology and its critical place in any robust energy mix has been under fire since the events surrounding Fukushima. Is the nuclear power industry and the advancements in nuclear technology misunderstood due to a false perception among the public and even some governments?
Well, certainly there's, over time, been a lot of debate about nuclear power and its role in our energy mix. And I, for one, believe that we need nuclear power in our energy mix, and that the benefits of nuclear power far outweigh any perception of risk associated with nuclear power. Even with the events of Fukushima, the technology that Nuscale is working on would not have had the issues that occurred at Fukushima. I mean, the technology has moved far enough along that even in some very extreme situations, we won't have the issues that happened at Fukushima or any other, of the problems that have been in the past from the large plants. And technology has moved far enough along that we can confidently say that this is a safe way of generating carbon-free electricity. And that carbon-free electricity, as we go into the future, in our mind is very very important for the world and for the U.S. as well, given that in today's world where we need all types of power, we need intermittent power such as wind and solar, we need baseload power such as nuclear power to be able to make sure that the lights stay on 24 hours a day, 7 days a week, and we need that to be carbon-free, given the problems associated with climate change. So, our technology and nuclear in general, I believe, has a role to play, and the perception of nuclear as a something to be feared by anyone is misplaced, in my opinion.
Right, and there's so many different avenues that the media or what have you and the public that does not fully understand how these systems operate, the controls that are in place to reduce risks since going back over the 63 some years of commercial reactor operating history. So folks really need to dig deep and take a look at the benefits that are provided and the real situation that occurs when there is a problem at one of these plants. I think people often automatically take it for, there's a hurricane coming to Florida, and look out, that nuclear power plant there is going to explode, and it's going to be like a nuclear bomb go off, and that's just not the case at all. So it's, in fact, is quite the opposite. They're extremely robust and are built to withstand significant severe situations. And with Nuscale is taking that to a level never seen before by the industry. So it's quite impressive, the work that's going on. So what can the nuclear power business do at this point to improve sentiment? And what is Nuscale doing specifically to kind of lead this effort?
That's a difficult question to figure out exactly how to change perceptions and change sentiment over time. First, I think it's slowly moving in that direction, given just the reality and the pragmatism of we want to have a carbon-free way to generate electricity, and that we need to have carbon-free way of generating electricity. And the reality that, at least for baseload technologies, the only real viable way to generate baseload electricity in a carbon-free manner that's scalable is nuclear. So I think perceptions over time are changing with that reality, and also with the reality of being able to talk about new technologies like Nuscale, and there are many other technologies that are getting developed both in the U.S. and internationally, which would address some of the problems of the past with nuclear power, which, as we talked about, really weren't huge risks to begin with. What Nuscale is trying to do is make sure that we provide the information to the public and through our website and through all of the marketing that we're doing, that we do believe that this is a technology that is needed and can significantly benefit mankind, not just people in the United States. Really, it's an international product. Many places around the world need clean, carbon-free baseload electricity. And we believe that we have a solution that provides that at a cost that is economic. And with that combination of things, we believe that this truly is a game-changing technology with respect to places all over the world. And it's not just for electricity. It can be used for heating loops. It can be used for desalination. It's more than just providing electricity. It's essentially a way to provide energy to places around the world that maybe haven't had the opportunity to have that energy like this in the past. Small modular reactors like Nuscale are able to go into countries that can't put onto their grid, a 1,000 megawatt or 1,200 megawatt unit. It just would be too much and too much energy to put on certain countries' grids. So
Sure.
the ability for us to be able to do that really changes the equation on nuclear power around the world. And as we go out and try to educate people on, what we're doing, what other new nuclear technologies promise can bring, I think that's the path to success that we'll have going forward to, not only bring this to deployment in the United States, which we're already on a path to deploy this first plant in the United States, but also to, convince and market to the rest of the world that this is a viable long-term solution for what we're doing.
Right. And I think that, especially here in the U.S., the Department of Energy, there needs to be a collaborated effort to come out and provide public awareness, whether it's the Department of Energy, the government, the various agencies involved, the NRC, FERC, if they're involved. These types of agencies need to do more on the awareness side. The utilities, the major conventional utilities in the United States need to do more on the awareness side. I think there can be a real effort too in some of the public figures and some of the larger investors that are backing this space. Some of the names, there's even some names in the media that are very popular folks, kind of a public eye, can provide awareness that are all pro nuclear technology, pro SMR. So I think there's a lot that can be done, and there's a lot of different avenues in which it can be pursued. So moving on to another question, we want to get in more to the details of the Nuscale technology. So kind of tell us about Nuscale and tell us about the major features of the SMR.
Sure. So an SMR, by definition, so small modular reactor, is a reactor that by definition is less than 300 megawatts in size. So Nuscale's individual reactors, which we call a power module, it produces 60 megawatts of electricity. It's about 180 megawatts thermal power. And it's, in that size that can be used, it can be legitimately called a small modular reactor. Now, we are able to gang or utilize a number of those modules in one plant to basically give a customer the opportunity to build anywhere from 60 megawatts to our largest plant configuration that we're working on right now is 720 megawatts. So it's scalable and truly scalable in 60 megawatt bite sizes, which makes it very attractive for some places around the world, as I was talking about, that really can't put 1,000 megawatts or doesn't need that much power on their grid. Some island nations or places that need, say, 300 megawatts, they could install 5 of our modules in one plant and provide resilient power that way. The heart of the technology is, a pressurized water reactor, which is the same technology that's been used both in the Navy and for our commercial power plants in the United States for, as you said, 60 plus years, and it's been used safely. And the technology that Nuscale has, one of the reasons why it is such a compelling safety case is because it's very passive. So the way the electricity is generated is by the creation of steam in a nuclear power module, and a nuclear power module is essentially essentially a thermos bottle. So we have a pressure vessel which holds the core, and in that core with nuclear fuel at the bottom, it heats up water. That water rises, and that water, as it rises and picks up heat, turns to steam. As it turns to steam, that creates steam that goes out into a secondary system to create electricity. And that water that's rising up in that thermos bottle, then as it loses its heat, it falls back down. And that's all done with gravity and convection. It doesn't require any pumps, any parts that are moving. It doesn't require a lot of things that are more associated with traditional nuclear power plants. So it's very simple and very safe. And not only is it safe, but because of that simplicity, it makes the modules very economic, because there just aren't a whole lot of moving pieces to this, what I'm essentially calling a thermos bottle. And it's also very safe because that thermos bottle, within, you have one shell and then a second pressure vessel around that shell. That's the containment. So that replaces what people traditionally think about when they see large nuclear power plants today. They see a big building, a big dome building that is meant to keep anything that might happen with respect to any emissions from a nuclear power plant out from the atmosphere. And we have this system where that's basically being done by these two metal shells. And even outside of those metal shells, that thermos bottle is placed in a pool of water, which is the ultimate heat sink. So if there's any issues, the water is already there to cool everything down, and it can do that indefinitely without any operator action. And that in itself is put in a seismic category 1 building, which is meant to withstand a 747 hitting the building. So a very robust system to actually generate electricity that, because of its simplicity, it's also economic, and we can build these smaller units economically, when most people would have said, well, in the past, nuclear power is all about the economics of scale. We're now turning that around and not doing economics of scale. We're doing economics of small, and being able to factory manufacture the portions of the power plant that are the sensitive nuclear portions, rather than having to build that on site, and makes it much more economic and much safer from a construction standpoint.
Right. Well, you said a lot there, and there's a lot of pieces that are important. For a country that doesn't have the budget to spend $5, $10, or $15 billion on a conventional large plant, can now look at scale and say, hey, we're gonna purchase some of these, and they're gonna do so at a much lower cost, and they can set up their system. And then with that too, it's my understanding that these individual modules, while can work all together, can also work independently. So if you have one that doesn't work or needs to be refueled, the other ones continue to work. And so it's a very interesting technology, and the fact that there is very, very little human interaction when these things are operating, because they kind of self-regulate, is also quite important, because you can say that some of these past events have been mostly on the human error side, and so forth. So it's interesting, the technology and kind of where it's going. So and Jay, feel free to correct me if I've got something incorrect here. Certainly step out and let me know if I've got my facts wrong. So with that, another important feature that's really interesting, which I don't know much about how it really works, maybe you can explain it. So the Nuscale SMR treats water. How does it do that?
Well, first, for the portions of the plant that where the water within the reactor components, that water is all in a closed system. So that water, and as well as the water that's in the pool, in general, is not being consumed. It's in a closed system. You obviously have some leakage and some makeup water requirements, but for the water usage for our plant, as in many plants that are steam-based, is mostly around cooling the steam down once you've used the steam to create electricity, to then use that water in the system again. And typically that involves using cooling towers, which are their ultimate heat sink often is a river or a lake or the ocean, because that's where most of the heat will typically go. The advantage of our plant is we certainly can use that type of system where the ultimate heat sink would be, a river, a lake, or the ocean. But our plant is not limited to being able to be cooled that way. There's also air cooling that can be done essentially by cooling towers that are cooled by the air. And by doing that, you're using much less water is being consumed and getting heated up. You are using a bit more electricity to move the airflow to allow for the heat to be taken out by the air, but that air cooling alleviates a lot of the issues of using a lot of fresh water to cool the plant. And it's a very novel way of which is not just available to our plants, but to a lot of other plants as well, to make sure that we are not overusing the fresh water source.
Okay. And so for the you mentioned desalination. How does it do this? And so essentially this SMR technology can potentially provide water, basically desalinate water. Is that how it works, or?
It could be, yes. So imagine, say, a 720 megawatt NuScale facility that has 12 modules in it. As you said, those modules are independent. So one could, if they want the plant to create both electricity and water, you could dedicate one or two modules to have the option of either creating electricity or creating water through a desalination system. So essentially, you're taking the heat that nuclear power plant is creating and the steam that that comes about from that, and instead of using it to make electricity by putting a turbine on the back end, you can also put a desalination plant on the back end to take that heat and that steam and use that to basically boil water in a desalination process to get rid of and basically make fresh water. And there are a number of different systems once you have the steam, different technologies for desalination that are on the back end that could be used and coupled with our plant. And the reason why that's fairly exciting for us is there are a number of places around the world that have contacted us and asked us about what is your business case for being able to create water as well. And we can walk them through the numbers and walk them through how this would work. And even within the United States, there have been people that have asked us, having the ability to have the option for a 60 megawatt module of either using that output to create electricity or to create water, and that can be switched on and off. So if the customer that owns the plant, if it's more economic for them to be making water because they can get more, it pays them more to produce water than it would to create electricity, they'd choose to create water. But there are probably times during the day when the electricity is worth more than the water would be. So it provides, owners that option to be able to, make that economic choice based upon what the markets are telling them. As well, it provides the option for, the general communities to have fresh water if need be and if economic. So it's a pretty compelling case.
Okay, and so all this is contained in a nice heavy duty capsule that can withstand an impact from a 747.
The nuclear power module, which is the thermos bottle I'm talking about, is contained within a pool of water which is within a seismic category 1 building, so a big concrete building that's designed to withstand a 747 hitting it. Correct.
Very good. No, that's impressive, and the extra optionality, the flexibility with a water, kind of a desalination system. Now, that's a big improvement in itself. But in addition to that, can it also treat, like, for example, storm drainage waters that you might have in big cities that just have a huge amount of drainage that's dirty?
It could. You could use the energy coming out of a NuScale facility to power, the systems required to do the stormwater treatment. The NuScale technology is not suited for actually doing the stormwater treatment, but just like a desalination plant, the energy that's coming out of a NuScale facility can power the desalination plant to create the water. And, essentially the NuScale Power module can create, it's an energy source, and that energy can be used for a multitude of different things, whether that's creating electricity or doing desalination, which may be desalination because of the electricity that the NuScale facility is providing. So it's the flexibility of taking that energy that's coming out of that nuclear power plant and using that for many different applications economically that makes the technology very compelling for other uses outside of electricity. Right.
And yeah, it's very, very attractive. And the strength of the materials that are going into this technology and so forth is probably next to none. I mean, even in Fukushima, with the epicenter of the earthquake there, some of the reactor facilities there that were closest to the epicenter did very well, and were in fact a fortress for the community to rally to. If you check the actual facts related to that incident, so it's impressive. So I can only imagine how even more robust this technology is becoming, and the thought process behind the designs.
And we've been having studies done, independent studies of how well our plant would operate, and continue to be able to operate after, major earthquakes. There was one that I just heard about this morning that was done. Academics did a study based upon an earthquake in Chile that was an 8.8, and they concluded that our plant was resilient enough to withstand an 8.8 earthquake that happened in Chile, and be able to come back online and be a first provider for electricity for, the recovery of the area once, in the aftermath of an earthquake. So it's a very resilient system and very seismically robust. We believe that you can build this plant, in most places around the world, virtually any place around the world, even in places that have, above average seismic issues. Right.
Okay. Well, yeah, no, it's interesting too, and we'll get into some other questions about the mobility of it here in a moment. So kind of switching subjects a little bit, who does NuScale see as major clients kind of coming out of the gate? Is the big focus on the existing utilities, government agencies, and big corporate clients?
Our initial focus right now is on a project that we're working on called the Carbon-Free Power Project. The sponsor of that project is a company called UAMPS, which is the Utah Associated Municipal Power Systems. And that first facility looks to be coming online in the 2026 timeframe in the state of Idaho. And we believe that that facility will garner U.S. DOE support to complete the facility, and that we're going to put a consortium of suppliers together to build this technology first in the United States. It makes a lot of sense in the U.S. for new nuclear to be in places like the western parts of the United States, where gas, our main competition, at least in the United States, as far as other generating technologies that are base load, would be natural gas combined cycle units. And Therefore, it makes sense where when natural gas is cheap, as it is in the United States, that places that would most likely build what we're doing when they have the option of building a natural gas combined cycle unit would be in places where gas tends to be more expensive and harder to get, like in the western part of the United States. So we are focusing a lot on individual utilities that we know are interested because of the characteristics of those utilities. They need baseload power. They need firming power to back up a lot of the wind and solar that has gone into their grids over the recent years. That includes not only domestic utilities, but we're talking to utilities in Canada, talking to utilities, on virtually every continent except Antarctica, with respect to, deploying the technology. And in some sense, it's not just talking to utilities, but in some ways, it's also, depending upon the country, it's talking to, the sovereign nation about their needs for power and about how, certain countries really need the power, need the generation, and to be able to finance plants in those areas of the world, it requires, some sovereign backing from the countries that are desiring to have the power put in.
Right. Okay. No, it's interesting, and of course, as you know, the regulatory hurdles that exist in the United States versus a place like a country in Africa or maybe an Asia type jurisdiction. There's obviously different time frames to commercial production in these areas, and certainly the NRC and the United States, of course, is the big hurdle, and yet the most solid market to deploy and test these. So it's certainly interesting that it's good that you guys are pursuing all jurisdictions and engaging with all different types of clients and folks in need. So Nuscale is not yet a listed company, but tell us about management briefly, the share structure if you want to, the major backers, and kind of how the company's set up and how does it raise capital?
Sure. So Nuscale currently has two major backers. I don't want to call them equity backers because one of those is Department of Energy that has been putting capital into Nuscale under cost share programs. So the Department of Energy, we've been very lucky and fortunate to have their commitment to help develop this technology. Initially, the technology, way back when it started in the year 2000, so this has been going for a while, even before Nuscale was going. It was started through a grant from the DOE to Oregon State University to develop a technology that eventually morphed into Nuscale technology. So DOE has been certainly instrumental along the pathway that Nuscale has taken since the year 2000 to keep us moving along, both from a financial standpoint and as well as a backing within the government to help us overcome what are some pretty big capital hurdles to be able to get something like this done. Most nuclear technologies, and I don't think I'm speaking out of school here, to get a nuclear technology like what we're trying to do through all of the regulatory hurdles and do all of the engineering to be able to prove that it's safe and that you can commercially build it is a proposition that takes about at least $1 billion in capital. And trying to run a company for many years on equity capital when you need $1 billion of capital has been challenging. Fortunately, we've had significant Department of Energy support. To date, DOE has put in a little more than $275 million of cost share funding into Nuscale. And on top of that, the other portion of the cost share has come from private investors, mainly Fluor Corporation, that bought a majority stake in Nuscale back in 2011. So from 2011 through today, the vast majority of the capital required to get us along that path to commercial viability have been provided by DOE and Fluor Corporation. Now, that being said,
Okay.
we are out, looking for equity to complete the journey that we're on. As you said, we're not a public company yet. We may be someday. That likely won't be for several years yet. We have several $100 million left to spend to get us to the point of being able to deliver on that first plant in Idaho by 2026. And we believe that we will continue to get some funding from the Department of Energy. We believe that we will continue to get some funding from our existing equity partners, but we're also out looking for additional equity partners to get us to the end of the line. And as I said, because of the length of time that it takes to do what we're doing and the large amount of capital it takes, sometimes that can be, it's a challenging proposition, but that challenge has over time been lessened by the progress that we've made and how much money has basically been spent on the technology to date. And therefore, it's gotten easier for us now to talk to other sources of capital, be that financial capital, other strategic players within our supply chain, to hopefully provide some additional equity capital to get us to the end of the line.
Right. Yeah, that sounds good, and hopefully there'll be some later on as the initial module gets commercial production and things go that route. It would be excellent to see the orders come in and the down payments and kind of get things off the ground and get going. So tell us about management, and then also with that if I recall, and maybe I could be incorrect, but is Bill Gates' TerraPower, have they been part of this as well?
Bill Gates' TerraPower has not been part of Nuscale. So they're a separate entity, which we've occasionally talked to, but they have no relationship with Nuscale. As far as our management team goes, we have a management team that has largely been in place for several years. Like I said, I've been at Nuscale for 10 years. Our CEO came to us from Fluor Corporation in the beginning of 2013. He's a veteran of both Fluor and other private enterprises, and also is held positions within the U.S. Chamber of Commerce, including chairman of the U.S. Chamber of Commerce. So he's been significant in helping us get our message out to people and helping us, move further along in our technology, and has been with Nuscale for, a significant period of time. Our chief operating officer has been with Nuscale a little more than 4 years now. He's a nuclear veteran with at least 30 years of nuclear power background. So he's a very skilled and experienced chief operating officer. And I could go down the management ranks, but we have a number of people that have been attracted to Nuscale within our management ranks, all the way down to our employees, even to the to the lower levels of our employees, people that are straight coming out of college, that really believe in this technology. They believe in the need for the technology and the need for nuclear power going forward, and we all believe that this technology can change the world and that we can make a significant difference going forward in the realm of climate change and carbon-free generation. And that promise has really allowed us to not only fill out the management ranks with very skilled and experienced folks, but also to be able to attract and retain the technical talent that's required to do what we're doing, because there aren't a whole lot of people in this world that know how to design a nuclear power plant. We've been fortunate to be able to have a lot of people come and move their families to Corvallis, Oregon, to actually be a part of this journey with us. And frankly, the team that we have is top notch and very refreshing, and it's one of the reasons why I've been here for 10 years and will continue to be here to see this through, because what we're trying to do is really meaningful to all of us, and we're all dedicated to making sure that we get to the end of the line and actually build a facility and build not only a facility in Idaho, but also around the world.
And yeah, it's interesting you say that. With the experts in the industry, there's not much talent in the nuclear industry across the board, whether it's upstream or downstream. There's just not a lot of talent out there. It's a very small group of people, but yet they provide a baseload power, specifically in the United States, that everybody gets to enjoy. So it's kind of a powered, if you will, or my iPhone or my electric car charges at night, thanks to a group of nuclear power professionals and workers and so forth. And it's really interesting, because it really is the backbone of the industry, or the energy mix in the United States, and especially more so as coal comes off and disappears, and people finally come to the realization that you can't cover the entire western states with wind turbines and solar panels, and there's got to be some other options, and natural gas isn't necessarily the best way to go either, because it's not carbon free, and quite honestly, the safety factors of it is not anywhere close to what nuclear has for a safety record. And last I checked, just recently, the nat gas price did just go up, and so the cost is not looking as attractive, and so the fuel inputs natural gas can be very detrimental when natural gas rises. Maybe back to levels it was before. I think folks started to believe that natural gas was something that would always be there, and it would always be cheap, and that may not be the case going forward. So another question, kind of switching gears a little bit, or just kind of talking about the major partner, Fluor Corporation. What do they do, Jay?
So Fluor Corporation is a major constructor around the world. So they build roads, bridges, power plants. They're a large construction firm. So their interest in Nuscale, and the reason why they've continued to back us from an equity perspective, is because they want to partner with us to actually build Nuscale plants. So Nuscale itself will not do the actual construction of the facility. That will be done by Fluor, and that is a large business in itself. Nuscale expects that, because of the large capital needs just to own the intellectual property associated with, a nuclear technology, which, as I said, is going to be more than $1 billion. That $1 billion is essentially intellectual property. We do not intend to manufacture the nuclear portion of the plant. We do not intend to build the plant. We're going to be looking to partners. We will not be operating the plant. We need lots of different partners that have that type of expertise to make all of this work going forward. And Fluor Corporation, is one of the largest construction firms in the world, has worldwide reach, and is doing, is invested in Nuscale not just to build a few plants in the United States, but also to build plants worldwide.
Okay. No, and I appreciate the clarification on that, and I think it makes sense to bring on the certain contractors and partners to get these different stages completed, and we'll chat about that just a little bit more in a moment. So Jay, we were kind of itching to ask you this. So we've got to know what the cost of one of these SMRs will be rolling out of the factory. Can you give us just a rough ballpark figure and the time to manufacture one of these?
Sure. So the figures that I'll talk about first are what would be considered first of a kind, and then I can comment on what we think nth of a kind will be once the plant's built a few times. There will be learning that will make the capital cost of the plant likely significantly cheaper. And we're talking, between first and nth of a kind, we expect the cost to go down by about 20%, and that's what industry, knowledge and industry, what's happened in the industry in the past would dictate that it should be about 20% cheaper after we built this a few times. We're roughly looking at, for the first of a kind plant, to be about $5,000 a kilowatt, and that's in relation, so a 720 megawatt plant times the $5,000 a kilowatt, you're talking $3.3 billion or so to build a 12 module 720 megawatt plant from a overnight construction cost. And then again, we expect that to be somewhere in the realm of 15 to 20% cheaper as we get to nth of a kind. And when you compare that capital cost with the capital cost of other generating technologies, say natural gas, which is our main competitor, at least in the United States, a natural gas combined cycle unit, the capital portion of that plant costs anywhere from $1,000 to $1,200 a kilowatt. So it's much cheaper to build the capital portion of a natural gas fired plant. The difference between that type of asset and what nuclear power and Nuscale offers is once you build a nuclear power plant, the go-forward costs are predictable and pretty much well known. So there isn't a whole lot of volatility in the uranium fuel, and uranium is not a large cost component of the overall levelized cost of electricity of a Nuscale or any nuclear power plant. So the real cost of nuclear power tends to be in constructing the facility, and that's where the risks are. Once it's built, we have at least a significant operating history in this country with nuclear power that once it's built, it operates for a long time at a competitive go-forward rate. Now you contrast that with a natural gas combined cycle unit. Nuclear and Nuscale has a high capital cost to put it in, and then a low operating cost going forward. And a low operating cost that we're designing the plant for 60 years. We expect it could actually operate even longer than that. A combined cycle unit costs only $1,200 a kilowatt roughly to build, but over time it requires significant maintenance that's costly, that adds to the overall capital required for keeping the asset going. And more importantly, you have that natural gas component, which while today natural gas is relatively cheap in the United States, natural gas is very volatile. I mean, you can go from $3 an MMBTU to $10 an MMBTU in a period of a few days or a week, given
right.
the natural gas markets and the way they are. You don't have that volatility in nuclear power on any operating cost. So, and also realize that natural gas is cheap largely in the United States. It has gotten cheaper in other places around the world because of the United States, because of liquefied natural gas and LNG being able to be transported and making natural gas a more global commodity. But natural gas at the $3 an MMBTU level in the U.S., which it's kind of been at right now, it's higher than that because of some issues going on in the gas markets and weather recently. But last few years it's traded at about $3 an MMBTU. In other places around the world, it does not trade at $3 an MMBTU. LNG in places in Europe and Japan are easily $6 to $7 an MMBTU, and then at some periods over the last few years, it's been as high as $12 to $15 an MMBTU. So,
Right.
By putting in nuclear power, you are locking in basically on a price for your electricity for a long period of time, and avoiding the volatility that might come from putting in a natural gas fired plant.
Right. It's certainly a couple comments on what you said. First of all, these nat gas plants aren't going to run for 60 years, at least in my view. I'm sure you see that they're running for a lot less than that, or the fact is, right. And with that too is there's not enough operating history to have a real good idea of really how long these things will last. But my suspicion is they will not be as robust, as long lasting as these nuclear facilities. It's pretty obvious that a natural gas burner is not going to last out like the components of a nuclear plant. So I don't see that it would last that long. And you have these input costs that are substantially different, whether you're in Australia exporting LNG from Australia to Japan, and the issues internally, domestically with the country, having issues with the prices that they charge ratepayers in the country versus the export rates that they're exporting at. The United States, it will be no different, and it's not going to be different this time. It won't be any different when the markets levelize out, and the cost of LNG, whether you're shipping it to Europe to counteract Russian pipelines or whatever it may be, these costs are substantial. And it's only a matter of time before the enjoyment of these low nat gas prices, start to creep up, and of course they have in the recent month or so, quite substantially. So it'll be interesting to see how that kind of plays out. So Jay, just kind of confirm me if I'm right on my math. So if I wanted to buy, or if Corvallis wanted to buy a 60 megawatt plant from Nuscale, they're looking at about $300 million.
If you only wanted a 60 megawatt plant, the cost would be higher than that. So there is some scale associated with putting, all the infrastructure, because you need to build a building around, which is a significant portion of the cost of the plant. So the numbers I quoted you, roughly $5,000 a kilowatt for the overnight cost of a plant is for a 12 module plant. It would be more expensive, and we actually haven't done all of the engineering and cost estimates for smaller facilities. No, you can't translate that for a 60 megawatt plant that it would just be $300 million. It would be more than that.
Sure, and I just did that in my ignorance, so I apologize. But with that too is, if you think about the solar panels and the cost of the solar industry, and the costs that have come down significantly, and the competitiveness that has come across in the solar industry, your guys' figures of 20% when these are produced on a mass scale, I think is quite conservative, and I think we'll see in the future that figure will be surpassed significantly. And so I think that there's a lot of promising improvements on the cost side, and already, just based on what you said, it already is competitive with the other energy forms. And then on top of that too is it offers carbon free, extremely low risk, certainly pouncing all of the other safety records of these other forms. Solar and wind out of the gate have already had a horrible safety record. Their carbon footprint is not that good either, and nat gas isn't much better. And we already know that coal is the worst of them all. So it's it certainly is promising, Jay. So it's good to hear that. So as far as other models, is there going to be anything smaller than 60 megawatts? Is there going to be in the future? Will there be analysis or consideration for 25 megawatts or 50 megawatt units for the purposes of mobility? Let's say, we already kind of talked about, the nuclear technology and maritime applications. and how that would benefit there. And then also, what about, emergency relief programs? Maybe Puerto Rico has a hurricane and they're out of power. How can these things be deployed in that application, maybe on a smaller scale? And then also, what about a mining project in remote Alaska or in the deserts of Africa where they need temporary power for a mining operation?
Right. So all of those are potential uses of our technology and viable potential uses of our technology. With respect to whether, we will have modules that are less than 60 megawatts, I think at some point, and, we have looked at, what would that look like to have because we could build a 10 megawatt module or a 25 megawatt module. At the moment, we're focused on getting commercialized the 60 megawatt module to be deployed in a 720 megawatt plant. But in the future, the possibility of being able to, have smaller module sizes certainly is there. And, even a 60 megawatt module has a lot of promise in places like remote communities and mining places. And because although it would be, as we talked about, more expensive on a capital cost basis to just put in 60 megawatts, usually what's your next best alternative when you're going up against in places like that is usually not natural gas, it's usually diesel fuel, which is extremely expensive way to generate electricity and also not very environmentally friendly. So, the scalability and the size of our module really does lend itself to these different applications and different ways to deploy the technology. We haven't worked through all of those yet because there's lots of different perturbations. But we intend in the future that we will. It all depends on, what the market needs. Right now, we're trying to get ourselves through the first project. Once we get ourselves through that, there's many different ways to look at this, many different perturbations that we believe, depending upon the different market, could be viable for us to look at and could be, very beneficial to other places around the world.
I appreciate the information on that. So switching gears over a little bit back to regulatory, how is the relationship with the NRC, and what is the remaining timeline in your view to get full clearances from the NRC to proceed towards commercial deployment?
Well, I would say our relationship with the NRC has been very good. We've been talking with the NRC well before we put in our design certification application in 2016. Is when we put the application in. We are the only small modular reactor technology, the only advanced reactor that is currently undergoing a review by the Nuclear Regulatory Commission. As I mentioned, we put the application in at the end of 2016. It got accepted, or under the NRC framework, they call it docketed, in March of 2017. And that kicked off a process that's nominally 40 to 46 months to complete the certification in the United States. And we can say that we are on or ahead of the schedule to get that certification completed and done. We've completed phase 1 of that certification. We're in the midst of phase 2, 3, and 4 because the way it works, there are different chapters in the document that the NRC uses to certify us, and some of those chapters are in further, some are in phase 2, some are in phase 3, some are in phase 4 of the review from the NRC. But we believe that we're on track to have the NRC essentially approve our design by September of 2020, and to have the rulemaking, which is the legal process that would happen thereafter, done by January 2021. That's that 40 to 46 month schedule that I was referencing before. We currently don't see anything that will stop us from completing that certification. And I would say,
okay,
the NRC has been very good in working with us because one of the challenges that we face, as well as many other reactors designs that are behind us, are, our technology is a little different than what's currently available today. So one of the advantages of our technology is that about 95% of it is the same as what you'd see in a traditional nuclear power plant today. But it's the things that are a little different that that get a lot of scrutiny and take a lot of time to make sure that they're, safe for the public, and that's what the NRC needs to do. And there are many other technologies that are, in development today. There's at least 35 other companies are working on new nuclear concepts in the United States and Canada. And all of those concepts will have similar challenges that we've had, which is, you need to, for something that's a little different, you need to be able to prove that everything is safe and within the public's interest, which we believe we have done and are continuing to do, and we'll get through that regulatory process. But yes, it is it's a costly and time-consuming process to get through a major regulator like the NRC, and many people behind us will be likely coming, in the coming decade to also go through the NRC process so that they can build the United States. And it is challenging, but we believe that we are firmly on the path to getting this done in the time frame and at the cost that we had projected it would cost. Right,
and it'll be good to potentially, get this through, and you guys as a first mover ahead of the ball, ahead of everybody else, is certainly good. And with the folks that are currently heading up those offices of concern, appear to be quite workable, and they understand the importance of getting this through. And with your guys' technology, PWR, that's good, having that in place. And then of course, using probably some of the same fuel mixes and same styles of fuel, which we'll discuss just briefly in a moment, makes a lot of sense to help push through and say, hey, look, this is nothing out of the ordinary. You guys have plenty of applications and plenty of information and historical evidence on some of these technologies. So that's also a good piece of the Nuscale story. Instead of trying to completely reinvent something, you guys are taking something, making it even better, and then with the making it where you can produce it in a manufactured facility. You guys have really just kind of looked at all the aspects and selected the keys that really make the most sense kind of across the board. So it's pretty impressive. So another question, Jay, that came across from one of our readers, Australia, a modern country that happily mines uranium, but has yet to deploy any form of nuclear power. These types of countries, specifically Australia, how does Nuscale plan to make an impact on the Aussie energy mix?
Well, certainly we have talked with and been in contact with people from Australia with respect to, potentially deploying Nuscale technology in Australia. We do think that, for lots of reasons, Australia would benefit from nuclear power for the same reasons that many other countries, would. That being, you have a technology that's carbon-free, that's economic, and it also provides you energy security, which for many countries is a key. The ability to not be beholden to a natural gas supplier or some other fossil fuel supplier that may not be within your country and that may not be, which you may not control. And Australia certainly has a lot of uranium, and it makes it seem to make even more sense to utilize some of that uranium in a Nuscale facility going forward. But we have been afforded the opportunity with both Australia and other countries to actually discuss our technology with people both within the government, outside the government, that are interested in potentially deploying the technology. And I would say that, over time, as Nuscale continues to develop and they can see that we're on a path to actually deploy the technology here in the near to medium term, that the pragmatism of climate change and energy security and all these things that are inherent in NuScale technology make it a pretty compelling case to bring it to countries that even may not have any history in nuclear power. And we've been talking to places around the world. I won't mention all the countries that have zero nuclear infrastructure, but they recognize the need to have clean, baseload, secure power. And when they look at the options that are in front of them, they don't see too many. And we are one of their few options that they can have to have that clean, secure baseload power.
Right. And having that NRC stamp of approval would be really key to be able to show that as evidence of the robustness of the technology to other jurisdictions, and whether it's a Canadian authority approval, the U.S. authority approval, and even a Japan NRA approval. Japan certainly has their challenges with weaning themselves off the LNG and getting back to restarting, which they've been doing. And so these regulatory agencies having these kinds of marks of approval, and even Jay, with that too, Russia, if I'm sure you've noticed because you follow it quite well, Russia has made a really big attempt to step out and to finance, to offer construction, to offer their reactor designs in these other countries. If you look at Saudi Arabia doing procurement for potentially doing reactors, and you have Egypt, and you have construction in Turkey, you have these different places that Russia has really, Argentina has really gone after promoting getting nuclear power into it. And it would be nice to see more of an attempt by U.S.-based nuclear technology to go after and compete in this market, because Russia certainly wants the business. They want to control the fuel cycle. They want to have those pieces, the financing. And so it's really interesting the global dynamics that are at play right now, and how Nuscale has an opportunity to really just disrupt the nuclear industry, if you will.
Yeah, and certainly that dynamic, that geopolitical dynamic is kind of, it's somewhat unique to nuclear power. I mean, you don't really talk about that with wind and solar and natural gas, other generating technologies. And you're right, one of the key components is, providing the financing for these plants, because although a NuScale facility is not going to be a $10 billion for each reactor, or $12 billion for each reactor, and then you got to build a couple of them, so you're into $25 billion worth of capital, which many countries simply can't do, and they need financing for that. But even a $3 billion power plant for many countries is difficult to finance. And certainly other countries like the Russians, to some extent the Chinese as well, and other countries are interested in pushing their nuclear technologies, and they can do that with state-backed financing. And currently, there isn't a real good option in the United States to do that. That may change over time, but that is part of the competitive dynamic, and we do certainly spend time talking to our government about that competitive dynamic, and about the geopolitical nature of the nuclear industry and how NuScale and thereby the United States can play in that realm.
Yeah, absolutely. And whether it's going, getting financing from international sources and so forth, the U.S. government has certainly fallen behind in this regard, and China and Russia have certainly taken market share on the global stage in this regard, and I think that it needs to be addressed and be considered. And I think there might be a little bit of a light coming out of the end here as things kind of progress with some different actions that are starting to occur. And of course, with your guys' voice there, it's also important as arguably the leader of the SMR space. So switching gears again, what are the major raw materials? If you can give the audience kind of just a rough brief idea, what are the major raw materials that Nuscale is going to need to manufacture the SMRs, and give us an idea of how you might go about that procurement.
Well, procurement will be a big part of what Nuscale will be about as we get into this phase, which we're currently entering, being able to deploy a plant. So we are in the midst of trying to figure out with a global supply base how to put together all of the different pieces that are necessary, not only for the nuclear part of the plant, but also for the balance of plant, turbines and lots of pipes and valves. Largely, when you get down to raw materials, it's a lot of steel and a lot of concrete. And for the most part, once you get past the nuclear portion of the plant, so that thermos bottle that I was referring to, the rest of the plant is, and that nuclear thermos bottle is about 30% of the capital cost of the plant. So the other 70% of the capital cost of the plant is largely, components and materials that people have been used to using for decades, if not 100 years. So it's essentially, it's a steam plant. It's the same back-end steam plant that would be on the steam system of a natural gas combined cycle unit. It's the same steam plant that's on the back end of a coal plant. Very well known, and frankly, we're in designing that balance of plant. A lot of it's going to be commercial off-the-shelf items, and that lends itself well to the economics of what we're trying to do with Nuscale. But certainly, we are entering that phase, that challenging phase of finishing a design and then using that design to actually deploy and buy all the materials for a customer to, deploy all of that. And that will be, that will take several years as we get ready to construct that facility in Idaho. And, 2019, 2020, we're going to be heavily into figuring all of that out so we can actually start doing construction on that facility. But frankly, that's also one of the reasons why, we get a lot of interest from places around the world, because they want, different countries around the world want to be a part of that supply chain, and it's jobs for their people. This plant, both in the construction and the operation of it, requires a skilled workforce, and is a relatively high-paid skilled workforce. So all of those components, as we figure this out, are really important to the ultimate deployment of the technology. But they're also a good story, and lend to the economics of what we're trying to do as we go into different places and pitch our technology.
Yeah, interesting. It'll certainly be quite a bit of different materials that'll go in here, and certainly, the steel, the strength of the steel, and the quality, and these different components that'll go into it. And obviously, we know that, the nuclear fuel, the uranium component of that as well. So it'll be fun to watch how you guys go about the procurement. And I know there's been some announcements with announcing, various suppliers and vendors that are starting to contribute towards this facility in Idaho. So it'll be good to watch that play out. So kind of on nuclear fuel side, as you know, the uranium mining business has suffered quite a bit since Fukushima. Supply from major producers has been significantly cut, and prices of uranium have been well below the cost of production for a number of years. As a result, a few U.S. producers have filed a Section 232 petition with the Department of Commerce that is pending an outcome within the next 6 months. What's your view on the uranium mining business at this stage?
Well, I can't say I have a real global view of the whole business. but I would say, you know, Nuscale endeavors to help the nuclear industry out, the nuclear fuel industry out, by serving a market that we think is huge. That there will be a very big market for what we're doing, and that will create a pull through for the nuclear fuel industry because this will require a lot of nuclear fuel going forward. So we are hoping that in our success, that will alleviate, you know, some of these issues that the supply chain on uranium, you know, that, you know, all of the issues with the declining nuclear base over time, that we will change that, and that the, you know, nuclear, or that the uranium suppliers will be happy to partner with us going forward to utilize their product.
Right. And with the Section 232 petition that's out there, I think hopefully there'll be some awareness raised when there is a decision rendered by the Department of Commerce and the President. I think there'll be some kind of a positive outcome in favor of the U.S. Producers, and hopefully that will start to raise more awareness about the national security interests and the issues that are being faced there with the you know, uranium supply and where it presently comes from to you know, more or less power these reactors that are in existence in the U.S. and of course resulting in the powering of, you know, public homes. So with that, on the same topic, Jay, if you don't mind, give us an idea of how Nuscale views the contracting throughout the fuel cycle. Does Nuscale plan to secure direct contracts from miners to conversion, to enrichment, to fuel fabrication, or is the company looking to contract out this entire fuel cycle procurement to a third party?
You know, certainly most of that is all up in the air. Currently, we do have a fuel supply agreement for the first plant, and that agreement is we contract out essentially for the fuel from a fuel supplier that will be providing you know, the fuel rods, not, you know, processed and all the way ready to be put into one of our plants. So somebody that would work back into the supply chain of the uranium supply chain all the way back to mining to be able to put that into a package that will sell to us to put into our plant. Actually, it would be selling to the ultimate end customer. So that's the model that's in place currently for the first plant. How that will work going forward is unclear. Although my own personal view is that that's likely the model that would go forward. I mean, that's the model that currently exists within the existing fleet of nuclear power plants. Is you know, there are a couple of global vendors for PWR fuel, and typically the existing nuclear power plants purchase their uranium fuel rods ready to be put into their plant from those vendors, and those vendors are not necessarily the miners of the uranium.
Right. So give us. I'm gonna bother you just a little bit more on this fuel side. So, for example, when you guys manufacture these in a facility, and you guys have, you know, manufacturing contractors have been set up and so forth. When these things are being shipped from the factory to the site, are these coming loaded with the fuel rods, or the fuel rod, is it loaded on site? And give us an idea with that explanation. Give us an idea of how long these modules operate without having to refuel, and then what is the rough consumption on startup and at refueling?
Initially, doing a fuel load for a new plant, first we will not be shipping modules with fuel in them. That would create all kinds of problems and makes little sense. We will be shipping the modules in their pieces to the site, and it will get fueled for the first time on the site. So, and that first initial fueling really looks an awful lot like just a regular refueling that'll occur on a 2-year periodic basis. So one of the other questions you asked is, how often do you refuel these? The way the supply chain is currently set up and the way under current regulation, we will be refueling the reactors every 2 years. So if you have a 12 module plant, we can take one module off every 2 years and refuel it while the other 11 modules are producing electricity, put it back, and then a month later, take another one, refuel it, take it offline, put it back, so that the refueling for a NuScale facility will become rather routine. And, not typically at a large power plant, nuclear power plant today, it's either an 18-month or 2-year fuel cycle, and you take the entire plant down, you lose 1,000 megawatts for a month to or 2 or 3 weeks. If they're really good at doing the refueling outage, bring a lot of people on to do that refueling outage, and then when you're done your refueling outage, the specialists all leave. Well, ours is going to be done a little differently and should be much more efficiently, because we're going to be doing a refueling of one module. Although it'll be every 2 years, we'll then go and do the next one, say a month later. And the reason why it's every 2 years is not necessarily that you couldn't put enough enriched fuel into one of these modules to have it operate for longer than a 2-year period before refueling it. It's more under current regulation with the NRC, we need to have certain components inspected on a 2-year basis. And we need to comply with that. We expect that once we have a plant operating and can show that it's probably unnecessary to do these inspections every 2 years, maybe the inspection frequency can be pushed out somewhat, then it's likely that our refueling, if the inspection cycle gets pushed out, that our refueling outages would be pushed out, and we'd use a different mix of fuel to allow us to, push out those refueling intervals. But the way it's set up right now is we will do, a traditional refueling, but it'll be a little different because it's going to be happening on a much smaller basis, because one module at a time over a 24-month period.
Okay. And do you have a rough the refueling time from the start of the outage till refiring? What's the time frame on that?
I believe, and I'm probably not the best guy to answer this question, but I believe that we're talking 10 days to take a module out and put it back in. Wow. Probably shouldn't quote me on that one though. It's a compressed time frame from what a traditional plant has to do, because it's much more complicated to do 1,000 megawatts core than to do a 60 megawatt core that's essentially the same type of fuel rods, but they're half height fuel rods. There's just much less to be done.
And with that, is the composition of the fuel for the NuScale SMRs, is it exactly the same as the big conventional PWRs, or is there new technologies, maybe a light bridge type technology that's being considered at this point to improve the safety ratings of these fuel assemblies?
Well, I would say that there are other fuel assemblies that we can potentially use and that we will look at using going forward. But we've made a conscious effort, just as we have in many other areas, where the path of least resistance to actually get the first plants up and going is to do things in the same way they're being done today. So our fuel is essentially the same fuel that's used in PWRs today. The fuel rods there's just fewer of them, and they're half height instead of the full height that you'd see in a larger plant. And we did that very consciously, just because we knew that we'd be able to get that through a regulator in a reasonable period of time, because trying to license a new fuel and new technology on top of trying to license a new technology like we're doing would only make it longer for us to get to market.
Okay. And that makes complete sense. It's very smart method and route to use. So, do you, Jay, realistically, how soon do you see SMR technology really becoming the focus of the nuclear industry? And maybe to clarify my question a little bit, do you see SMRs as really, in the coming decades, as really the future of nuclear power?
Well, first, we think that we are already becoming to getting the point of being a focus within the, at least the new nuclear industry. Notwithstanding that we have lots of reactors already today operating, and there's issues around keeping those operating and continuing going forward, which are separate from issues around putting in new nuclear. But with respect to new nuclear, and clearly we're not the only, the only possibility out there. There clearly are other, the large reactors are still out there. Our view, at least in the United States, is that it's unlikely that anybody's going to build, either the EPR, which is what had been the Areva technology, I guess it's now owned by EDF, in the U.S. any longer. That it's unlikely that any AP1000s, given what's happened in Georgia and South Carolina, that any more of those will get built in the United States. It appears to us that if there's going to be any new nuclear in the United States, and the only one that's really has any legs is the one that we're working on right now in Idaho, that it will be new nuclear technology, not the existing large plants, at least in the U.S. Certainly around the world, there are countries that are looking at, should they be building large reactors? Should they be building small modular reactors like what we're doing? And we certainly get a lot of interest from people with respect to now looking at our technology and seeing it as viable going forward than we would have, certainly 10 years when I got here. It was difficult to get anybody to consider what we were doing at all. That has completely changed. I believe that SMRs and NuScale in general going forward will do well in the generating marketplace for a lot of the reasons that we've talked about. There are other competitors there, but if you look at what's currently available, we look pretty good, especially in the time, to be able to deploy a small modular reactor technology, at least in the timeframes that we're talking to in the 2020s. It's very promising for us, and it's difficult to contemplate other small modular reactors or other advanced reactors being built in that time frame.
Right, and I think the peers are watching, and I think they get that there is something going on here that is quite attractive. And some of the, if these the NuScale SMRs can scale even higher than some of the upper limits presently being looked at, to compete with some of these massive conventional reactors coming online in China right now. I think that there is a significant market, and the fact that they can be, taken offline independently, refueled, and continue to run grid power from the others is very, very attractive. And so I think you guys are onto something quite interesting. And the approach is very unconventional, but makes a lot of sense, and is very smart in my view. So I think that there's going to be quite an adoption going forward as we kind of come out of the gate. And I think it really just hinges on you guys getting those approvals and getting some of those initial prototypes and reactors out there at Idaho, and getting some of this other stuff off the ground. I think those will be kind of the groundbreakers that are really get focused on it. So, Jay, is there anything that you'd like to add about NuScale that we didn't cover?
Well, I think we we covered an awful lot. And certainly I appreciate all the questions and all the discussion around what we're doing, because getting this out to people and getting, especially those in the financial community, more up to speed on what we're doing, to us is extremely valuable, because we need, not only does Nuscale need capital, but there's going to be a lot of capital that needs to be deployed just in building plants, whether that's our plant or somebody else's plant. And extremely valuable to be able to walk through our story with you, and hopefully have your listeners listen in. And really, I think we pretty much covered the whole gamut of it.
Oh, good. Well, for those who want to learn more about Nuscale and those who want to know about investment opportunities with the company, where should they go?
Well, certainly, with respect to investment, they should contact me, and my information is up on our website. And generally, our website is a very good source of information for anybody interested in learning anything about Nuscale. That website is www.Nuscale Power, which is NUSCALEPOWER.com. And I'm up there with my contact information with respect to any potential investors. And there's also a wealth of information on there with respect to technically what we're doing, and how we're looking to bring this to market.
Okay, and Jay, you guys are Nuscale's open, accredited investors, and of course anything above that.
Correct. So we are a private company currently, structured as a limited liability company, and so we're not out doing a general solicitation, but we are out looking for investors that are accredited, that meet the SEC requirements for accreditation, that could put capital in, and the levels of capital we need are such that we typically won't talk to somebody that has $100,000 or $200,000. Unfortunately, the bite size that we need is more in the millions of dollars per investor, given our burn rate and the work that we have to do going forward. But we are interested in talking to anybody who could meet that criteria and is accredited in the United States.
Okay, well, that's good information, Jay. Appreciate that. Well, it's been a pleasure. Good luck at Nuscale, and we appreciate you taking the time.
Well, thank you very much. I really appreciate all the discussion and all the time you've taken to hear our story. Thanks.